So I guess we're through with conduction and convection, both for plain walls and pipe. So proceed na tayo sa next mode ng heat transfer, which is the radiation. Now, kahit anong bodies that has a certain temperature, nag-i-emit talaga yan ng radiation. So yung concern natin dito is the rate of heat transfer between the bodies due to radiation. Okay, so yung direction ng Q is always from the higher temperature body to the lower temperature body. Okay, so yung formula natin for the rate of heat transfer due to radiation is ito. Yung epsilon times sigma times area, then times the higher temperature raised to the power of 4 minus the lower temperature raised to the power of 4. Okay, so take note of this kasi importante ito. Dito sa radiation, lahat ng temperatures should be absolute. Okay, so kapag SI, plus 273, kapag English, plus 460. Kasi yung mga temperatures dito, naka-raise to the power of 4. Unlike doon kanina, sa mga delta T, walang exponent, so okay lang kahit hindi naka-absolute. So ngayon, ano naman yung epsilon sa kayong sigma? So yung epsilon is actually the emissivity or the emissive power of a radiating body. So usually, given yan sa problem. Now if hindi given sa problem, you can assume na yung body is a black body in which the emissive power is equal to 1. Now kapag sinabi nating black body, it does not necessarily mean na yung body is color black. Kasi yung definition natin ng black body sa heat transfer is actually a body that is ideal for heat absorption. So ibig sabihin, lahat ng heat na itatransmit is i-absorb ng black body. Okay, so next, yung sigma naman is called the Stefan-Boltzmann constant. So yung value niya is 5.67 times 10 to the power of negative 8 watts per meter squared Kelvin raised to the power of 4. Okay, so yung sigma is actually the constant 31 in your calculator. Okay, so check natin sa calculator kung yan nga ba. So sa calculator, press shift, then constant. Then type 31 kasi constant 31. So it is actually yung sigma sa calculator. Then press equal. So yun nga ang kanyang value. 5.67 times 10 to the power of negative 8. Okay, next. Problem number 10. The temperature of the flame in a furnace is 1,277 degrees Celsius. And the temperature of its surrounding is 277 degrees Celsius. Calculate the maximum theoretical quantity of heat energy radiated per minute per square meter to the surrounding surface area. Okay, so yung pinapahanap is Q over A. Kasi nga per square meter daw. So heat through radiation. So we have the formula Q over A is equal to the emissivity, then times the sigma, or this is the Stefan-Boltzmann constant, then times the absolute temperature, the higher one, raised to the power of 4, then minus the absolute minimum temperature raised to the power of 4. So huwag kalimutan kapag sa radiation, gawin talagang absolute yung mga temperatures. Okay, so hindi given yung emissivity, pwede natin siyang i-assume as black body. So that is why yung emissivity is equal to 1. Then take note na yung black body is the most ideal body for heat transfer. So therefore, it has the maximum energy radiated. So meron pala tayong keyword from the problem. Maximum theoretical quantity of heat radiated. So pwede mo siyang i-assume as black body. Then yung Q over A, represent lang natin as small q. Okay, so yung sigma, again, is 5.67 times 10 to the power of negative 8. So yung sigma, if hindi na memorize, you can just use yung calculator. So that is the constant 31. Okay? So makikita sa calculator yung sigma or yung Stefan Boltzmann constant. That is constant 31. Then times yung temperature difference. So we have 1,277 plus 273. So again, huwag kalimutan, sa formula ng heat transfer through radiation, dapat naka-absolute value ang temperature. So raised to the power of 4 minus the absolute minimum temperature, 277 plus 273 raised to the power of 4. Okay, so using your calculator again, masasolve natin yung value ng small q, or that is q over area. So small q is equal to 322,084.35 watts per square meter, or that is joule per second per square meter. Now take note na sa problem, dapat ang unit is kilojoule per minute per square meter. So ko-convert natin yung joule to kilojoule as well as yung seconds to minute. So multiply by the conversion factor. In 1 minute merong 60 seconds. So cancel out ang unit na second, then convert natin yung joule to kilojoule. So 1 kilojoule is equivalent to 1,000 joules. So cancel out yung unit na joule, therefore yung matitirang unit will be kilojoule per minute per square meter. So therefore yung final answer natin should be 19,325.06 kilojoule per minute per square meter. Okay, so going back sa problem, your final answer should be, so it should be letter A. 19,321.65 kilojoule per minute per square meter. So just choose yung pinakamalapit na final answer. Okay, so proceed tayo sa next problem, number 11. The hot combustion gases of a furnace are separated from the ambient air and its surrounding, which are 25 degrees Celsius, by a brick wall 0.15 meters thick. Okay, so you can imagine hot gases and air being separated by a brick wall. Then yung temperature daw ng ambient air is 25 degrees Celsius, separated by a 0.15 meters thick na brick wall. The brick has a thermal conductivity of 1.2 watts per meter Kelvin and a surface emissivity of 0.8. Under steady state conditions, an outer surface temperature of 100 degrees Celsius is measured. So yung 100 degrees Celsius is actually the outside surface temperature ng brick wall. Then, free convection heat transfer to the air adjoining this surface, so this surface refers to the outside surface, is characterized by a convection coefficient of 20 watts per meter squared Kelvin. So, this statement means na merong convection heat transfer or convective heat transfer between the outside surface ng wall saka sa air. Then given yung H, which is equal to 20 watts per meter squared Kelvin. So the question is, what is the brick inner surface temperature? Okay, so yung answer is actually 365.04 degrees Celsius. So titingnan natin paano nakuha yung answer na yan. Then para mas ma-visualize natin, let us illustrate yung problem. Okay, so meron tayong brick wall 0.15 meters thick, which separates yung hot gas and yung ambient air. So yung pinapahanap sa problem is the inner surface temperature ng brick wall. So given yung outside surface temperature, which is equal to 100 degrees Celsius, then given din yung ambient air temperature, which is 25 degrees Celsius. Okay, so given din yung following, emissivity, that is equal to 0.8, thermal conductivity ng brick wall, that is 1.2 watts per meter Kelvin, then given din yung film coefficient, which is equal to 20 watts per square meter Kelvin. So, paano natin makuha yung inside surface temperature ng brick wall? So, para makuha natin yan, kailangan natin ng counting analysis. Okay, so let's take the outer surface ng wall as our system. Then, recall natin yung first law of thermodynamics, which states that all energy entering the system is equal to all energy leaving the system. Or energy in is equal to energy out of the system. Okay, so kailangan pala identify muna natin yung mga energy entering the system saka yung leaving the system. Now take note na yung system natin is the outer surface ng brick wall. So identify muna natin yung energy entering the outside surface ng brick wall. So take note na yung temperature inside or the inside surface is greater than the temperature, the outer surface ng wall. Kasi meron tayong hot gases sa loob ng furnace. Therefore, meron tayong heat through conduction from the inner surface to the outer surface. Okay, so yung medium natin is a solid brick wall, which is why yung heat is transferred due to conduction from inside to the outside surface. So ito actually yung ating energy entering the system. Q due to conduction. Then take note, it is clearly stated in the problem na merong heat transfer between the outside surface and the ambient air, and that is due to convection. Then given tayo ng H, which is the film coefficient between the outside surface and the ambient air. Then since merong temperature difference between the outside surface ng wall as well as the ambient air, magkakaroon din yan actually ng heat transfer due to radiation. Okay, so yung Q due to convection saka yung Q due to radiation are actually the energy leaving the system. So again, yung system na kino-consider natin is the outside surface ng brick wall. So therefore, from the figure, pwede pala natin i-rewrite yung energy equation as Q ng conduction equal to Q ng convection plus Q ng radiation. Okay, so let's try to expand yung equation. So Q due to conduction is actually thermal conductivity ng material, then times the area ng wall, then times the change in temperature between the inner and the outer surface ng wall. So that is Ti minus To. Then divided by the wall thickness, which is yung X. Then yung Q due to convection is H or yung film coefficient times the wall area, then times delta T. So yung delta T dito should be the outside surface temperature ng wall minus the ambient temperature. Kasi if we go back to the figure, so yung convection is actually from the outer surface to the ambient surface or to the ambient air. Okay, so which is why yung delta T is To minus Ta. Then ganun din sa radiation. So yung heat transfer is from the outer surface ng wall to the ambient air. So yung Q by radiation is the emissivity times the Stefan-Boltzmann constant times the wall area, then times the absolute temperature ng outer surface raised to the power of 4 minus yung absolute temperature ng ambient air raised to the power of 4. Okay, so kung mapapansin nyo na yung area sa whole equation is makakancel out lang. Okay, so plug in natin yung given, yung thermal conductivity, that is 1.2 watts per meter Kelvin. Then times the quantity, so yung inner temperature ng wall ang hinahanap natin, minus the outer temperature ng wall, which is equal to 100 degrees Celsius. Then divided by 0.15. So this is the wall thickness, 0.15 meters. Then equal to, yung film coefficient is 20 watts per meter squared Kelvin. Then yung outside temperature ng wall is 100 Celsius. Yung ambient temperature naman, that is 25 Celsius. Then plus, yung emissive power is given sa problem, that is 0.8. Then yung Stefan-Boltzmann constant is 5.67 times 10 to the power of negative 8. So again, kung hindi to na-memorize, makikita yan sa calculator. That is constant 31. then times the quantity. So outside surface temperature, that is 100 Celsius. Then plus 273, magiging 373 raised to the power of 4. So do not forget to make it absolute. Basta Q due to radiation. Then minus yung 25 Celsius na ambient air plus 273, that is equal to 298 degrees Kelvin. Then raised to the power of 4. Okay, so ito yung equation natin. Then yung unknown is only the temperature ng inner surface ng wall. So therefore, using your calculator, masasolve natin yung T sub I, which is equal to 365.04 Celsius. Okay, so again, nakuha natin yung temperature ng inner surface ng wall using the first law of thermodynamics. So yung energy in is the Q due to conduction, then yung energy out is yung Q due to convection, saka yung Q due to radiation. So the final answer is 365.04 Celsius.